In this video, I'm going to go over a few questions on the test review for topics 1.7 to 1.10. So looking at these first few questions, making sure that you understand that we're writing the left and right end behavior. So you're looking as the graph goes to the left, as the graph goes to the right, making sure that we write our limit statements correctly based on what it's asking. Okay. So I don't have any doubt that you're good with numbers 1 and 2, but I wanted to look more at these questions down here. Okay, so remember that limits to positive and negative infinity are the same thing as horizontal asymptotes. So this right here is important. So if it's asking you about the left and right end behavior, then this is what it's asking for. It's asking for the horizontal asymptote. So let's take a look at this one down here because I have a feeling this would be the one that we have the most trouble with. So if we look at this, what I think is easiest for us is if we rewrite this as 3 times x minus 1 times x minus 1 times x plus 5. If we were to think about multiplying it, we would multiply the 3 times x times x times x. And so that would give us a leading term of 3x to the third power. On bottom, we could rewrite this as 2x plus 3 times 2x plus 3. If we were to multiply this out, we would get a leading term of 4x squared. So this is a case of bigger on top, which means there's no horizontal asymptote. Okay, so that means that your left and right end behavior are going to go towards positive or negative infinity instead of a number. So to figure out what number, first off, let's write our limit statement for the left side. So the left side is as x is approaching negative infinity of m of x. What we're going to do is we're going to take the left or the leading term on top and the leading term on bottom, and we're essentially going to think about plugging in negative infinity. So if I have 3 times negative infinity to the third and then 4 times negative infinity to the second, that would give me a negative on top and a positive on bottom, which overall equals a negative. So this is going towards negative infinity. If we think about the right side, that would be as x is approaching positive infinity of m of x. We would think about plugging in positive infinity. So that would be a positive on top, a positive on bottom, which overall equals a positive. So this is going towards positive infinity. Okay, so remember, this is where on questions specifically 3 through 6, this is where you're looking at Bobo, Botan, and Eats DC. So remember, bigger on bottom, the asymptote is 0. Bigger on top, there is no asymptote. And if the exponents are the same, then you're going to divide their coefficients. So you will use that anytime it's asking about end behavior or horizontal asymptotes. Okay, now on the next page, this is where you have to make sure that you're only writing what it asks for. So in this case, let's take a look at number 7. So it's well, first let's read the directions. Write the limit statement describing the output values for the following graphs and verbal descriptions of the input values. So you're only writing what it asks for. So it says the input values decrease without bound. The input values, okay, that's our x values. When it says that they are decreasing without bound, that means that they're approaching negative infinity. Okay, so this tells us about the left side of the graph, or it's asking us about the left side. So when we write our limit statement, that would be the limit as x approaches negative infinity of f of x. Well, as we look at the graph, as it's approaching negative infinity is over here. What are the y values doing on the graph? Well, the y values are going down. The y values are going down. So that means that as we go towards negative infinity, our y values, f of x, is going towards negative infinity. Okay, so on these, we're making sure that we only write the limit statement that it asks for. We're not writing anything more. So I don't want you writing the right side, just the left side. Now, if we look at number 8, the input values increase without bound. So again, input values are talking about your x values. If it's increasing without bound, then it's going towards positive infinity. If it's going towards positive infinity, that is the right side. Okay, so as we go towards positive infinity is over here. As we go towards the right, what is our graph doing? And it's going flat, and it's going flat towards that horizontal asymptote. So when we write our limit statement to represent the right side, x is approaching positive infinity of g of x. And what is it approaching? It's approaching that horizontal asymptote at 1. Okay. Now, looking at the bottom half of this page, the graphs of the functions h and k are given below. Use the graphs to find the following limits. So what I need you to understand is the difference between the limit statements when it's talking about a vertical asymptote, a horizontal asymptote, a hole. Okay, so if we look at this, it says the limit as x approaches 2 from the left side. So remember, this right here means the left side. And then if you look at number 10, we're approaching 2 from the right side. So if we're approaching 2 from the left side, that means we're moving towards 2 on the left side. So 2 is right here. So if I'm approaching it from the left side, notice that the graph is going down. Since it's going down, it's going towards negative infinity. If we want to approach 2 from the right side, if I'm approaching it from the right side towards 2, it's going up, so it's going towards positive infinity. So if you look at this, when you have x approaching a number from the left and the right, and it equals negative or positive infinity, what it tells you is that that is where there's a vertical asymptote. So if you're just given a limit statement, then if you see that it's approaching a single number from the left or the right, and it's equaling positive or negative infinity, that tells you you have a vertical asymptote. Okay. If we look at number 11 and 12, so this time we're approaching the number 3 from the left and the number 3 from the right. So if I'm approaching 3 from the left, that means I'm approaching right here. And it looks like I'm approaching the y value of 3. If I approach 3 from the right, notice that I'm also approaching that same y value, which is 3. So notice that when we're approaching a number from the left and the right, and it's equaling a number, that's when there is a hole. So this is like what we need to know. When x is approaching a number and it equals infinity or negative infinity, you have a vertical asymptote. When x is approaching a number and it equals a number, you have a hole. Now, because the limit from the left and the limit from the right on 11 and 12 equal the same thing, this could also be written as just the overall limit as x approaches 3 of h of x equals 3. So because the left and the right equal the same number, then you can drop the left and the right notation and just say the overall limit equals 3. Okay. Now, On the next part, I just want to look at these last two questions. Okay, so notice now x is approaching negative or positive infinity. So I need you to know that these are going to talk about the horizontal asymptote, which in turn talks about the end behavior. So if we look at this graph, notice there's not a horizontal asymptote on the graph of k of x. So that's where you have to pay attention. What is the graph doing from the left or as you go towards the left, and what is the graph doing as you go towards the right? So as I go towards negative infinity over here, if I'm following my graph, it's going like this. And since it's going up, it's going towards positive infinity. If I look at my graph and I go to the right, notice that it's going to the right and down. And since it's going down, it's going down towards negative infinity as we move towards positive infinity. So just looking at the ends. So based on the limit statements, if you're just given limit statements, you have to be able to tell the difference between a vertical asymptote, a hole, and a horizontal asymptote. Okay, horizontal asymptotes can equal numbers or positive or negative infinity. Okay, now I do have that written right here as a little note. So limits approaching an x value that is a whole equals a number. Limits approaching an x value that is a vertical asymptote is equal to plus or minus positive infinity. So you'll use that same concept here when you're writing the left and right end behavior for that part. Okay, the next part is making sure that you know how to determine if there's a hole versus a vertical asymptote. So something you need to know is if there's a bigger multiplicity on top, it's a hole. If it's a bigger multiplicity on bottom, there's a vertical asymptote. So if we wanted to take a look at 25, okay, notice that I have x plus 3 on top and bottom. But this has a multiplicity of 5. This has a multiplicity of 3. My multiplicity is bigger on top, which makes this part right here a hole because the multiplicity is bigger on top. So this has a hole at x plus 3 equals 0. So we subtract 3 from both sides, and we get x equal to a negative 3. When we look at the second one, notice now the multiplicity of 5 is on bottom with a multiplicity of 3 on top. Well, this time the multiplicity is bigger on bottom, which makes that a vertical asymptote. So since it's a vertical asymptote, that means we have one at x minus 5 equals 0. So then we add 5 to both sides, and we get x equal to 5. So that's how you determine a hole versus a vertical asymptote. If the multiplicity is bigger on top or they're the same, it's a hole. If the multiplicity is bigger on bottom, it's a vertical asymptote. Okay, so that's what you would do for 20 through 25. 22, 23, and 24, you will have to factor first. And notice that on 24, the denominator has a greatest common factor of x, so you would need to factor that out first before you factor the rest of it. Okay. Then we have some inequality notation problems. So 27 and 29 are nice because it's already factored for us. 26 does not need to be factored, but 28 does need to be factored first. So remember, always find your zeros, then where the graph is undefined, and then make your number line. So I will show you what number 26 looks like, and then if you have questions on the others, you can ask in class. So first thing you want to find is the zeros. So to find the zeros, you will set the top equal to 0 as long as it's not a hole, and this one doesn't have any holes. So we would add 3 to both sides. We would get x equals 3. Then you would find where it's undefined, but now we know that this is a vertical asymptote, but it's okay just to call it undefined because it is undefined. So x plus 2 equals 0. We would subtract 2 from both sides, and we would get x equals negative 2. From here, we would go to a number line. And remember, on our number line, we would put anything that's undefined and anything that is a 0. And so what we're looking for is whether it's positive or negative on this interval. Remember, over here is negative infinity, over here is positive infinity. So if we plug in a number between negative infinity and negative 2, that would be like negative 3. So I would have negative 3 minus 3 over negative 3 plus 2. That would give me a negative over a negative, which turns into a positive. So that interval is positive. Looking at the next one, negative 2 to 3, I would plug in 0. So 0 minus 3 is negative, 0 plus 2 is positive. A negative divided by a positive is a positive, is a negative. And on that interval, this would be negative. If I look at my last interval, 3 to infinity, I could plug in 4. So 4 minus 3 over 4 plus 2. That would be a positive over a positive, which equals a positive. So then it comes down to what are we looking for? We're looking when x is, or our function is less than or equal to 0. Less than or equal to 0. So we want it to be negative or 0. So since we want it to be negative, that means that we're looking at this interval. Now, when we write our solution set in in interval notation, that means we're starting at negative 2 and we're going to 3. Negative 2 is undefined. Since it's undefined, it gets a parentheses. 3 is a 0, and we want it to be negative or 0, so it's going to get a bracket, and that would represent our solution set. Okay, so you would repeat that process throughout here. The next one is just based on this information, being able to find the correct equation that matches it. So knowing what it looks like to have a horizontal asymptote, what it looks like to have a hole, what it looks like to have a vertical asymptote. So I think y'all can do that. 31, same concept. It gives you information. You're trying to find the right equation. Okay, 33 is making sure that you understand the multiplicities that we talked about up here with 25. So for 33, you can look back at 25. Okay, 34 is talking about a horizontal asymptote. So with this, you just have to be careful with it whenever you're combining like terms. Okay, 35, make sure you factor. Remember that in order to be a 0, you would have to set just the top equal to 0. So when you're looking for zeros, you want the top, but you need to factor first and make sure there's no holes. Okay, make sure there's no holes, and then anything left on top, you'll set equal to 0. And then 36 through 30 or 41 is just looking for the horizontal asymptote if there is one. So that's using the Bobo, Botten, and EATS-DC. So if you have any questions, make sure you ask before your test. That way you can get help.